I think we're good. Yep, should be good. I'm hoping. I need to turn this music down just a bit, or more than a bit, but okay. So welcome back to the Pong series. Today we're just going to be continuing on with where we left off. So last time we just created the paddles, had our objects, and then placed them, allowed some input so we could move them. Now we're actually going to be looking at the physics of the actual Pong ball itself, and how we can represent that using using our graphics. So we'll see and this is all going to be in 2D. So we'll also be looking at collisions, which should be pretty interesting. So first thing I want to take care of is I want to go over some stuff in oh no. Okay. So I want to explain a little bit of a couple concepts in the on the drawing pad first before we actually get anywhere. Okay. So when we get into the code, we'll make some structures and stuff, and then we'll actually look at how to represent this in code. But I just want to go over the concepts first. So we're going to be working a lot with something called vectors today. And if you watch the other OpenGL tutorial, you'll know all about vectors. So essentially, you can have a couple components in a row or whatever. So it's used for velocity, position, acceleration, force. The list goes on. So many things in physics are represented using vectors, and for our purposes, we're going to be using 2D vectors, which means that they have two components, an x component and a y component. We're only going to be looking at velocity and position today in vectors, just because we need an x coordinate, a y coordinate, and then also for the ball, we'll need a change in x and a change in y, which is the velocity. Yeah. So in the kind of how it will connect this to our ball is in the main loop. We have let's say our ball's at this coordinate, which is x1, y1, and we have a velocity vector that goes like that. Then the next coordinate will be some multiple of this. And then it'll be here in the next frame. So x2, y2. And what will actually happen is x2, y2, the triangle brackets are used to represent vectors, by the way. So x2, y2 is equal to x1, y1 plus the velocity vector times dt, where dt is the change in time. So we have delta time in our program, which we calculate every frame. Let me just find it. It is right here. So when we say glfw get time, that's used to calculate dt. All right. Now in collisions, so we can just do this for however long. But remember, we're gonna have to work with collisions at some point, just because because we don't want the ball just to go through the walls. We want it to bounce off the walls. We want it to bounce off the paddles, so on and so forth. So in collisions, the way that we'll be assuming is completely elastic collisions. So no energy is lost at all. So for our purposes, I'm going to say elastic. So no loss of energy, which means, that the velocity doesn't decrease. And then what this also means is that, well, it's not independent of this. We're actually going to allow the velocity to increase. If you've ever played Pong before, the ball gets faster and faster as it's bounced off the paddles more. So every time we hit it with a paddle, we want to give it some sort of energy, which will just give from the paddle. So if the paddle's moving with some velocity in the y direction, we'll just essentially give some of that energy to the Pong ball, and it'll move faster. And if you get sick at the game, you can just keep it in there where it goes infinite speed, something like that. But we'll look at what that means in the code. So in collisions with the wall, energy stays the same once again. The energy will stay the same, and all we're going to be doing is we're only going to be concerned about the collisions we're going to be concerned with collisions in all the walls. So if this is our box for the scene, essentially, something like, if I could, let me just get a freaking box. I cannot do this. Here we go. Oh, there we go. Okay. So let's say this is our screen, right? We have some height, and then we also have some width. Remember, we're using the bottom left as 0, 0, and we can use an orthographic projection to make it like this instead of the top left being 0, 0, and this is going to be width, height. So if our ball is over here, and we want to test, is it colliding with the wall? All you have to do is just say, okay, get the position, so center, and you want to determine if it's within a ball radius of the height, and down here if it's within a ball radius of 0. And then on the left and right, same thing, just within a radius of the width or 0. So it all depends on the positions. Now, if it's left and right, we'll be awarding points to whichever side it got onto, so we'll implement that probably next time. But if it bounces off the top or the bottom, what we want to do is, if it's going with the velocity like this, like so VI, we just want that to be reflected completely, VF. Now you might be thinking, okay, reflections, is that light? Yes, it is light, and because we're assuming perfect collisions, we're going to be assuming that this reflection is across a normal vector. You probably know what a normal vector is because we've looked at it in our 3D models. And because this wall is just flat, it's going to have a 90-degree angle, so therefore the angle will stay the same. The theta is the same on both sides of the normal. So as a result, all we have to do is just negate the y component. So after a collision with the top or the bottom, all we got to say is v fy is equal to negative v iy. So just negate the y component, and then that will allow us to kind of simulate that collision with the top or the bottom wall. Alright, now for the paddles, however, it's going to be a little more different, but I'll go over how the velocity changes first, and then we'll go over on collisions, or how to detect them. I probably should have done that first, but this is collision reaction or resolution, I think it's called, but I'll just call it reaction, because that's easier to understand first. So now with the paddle. So if it collides with the top or the bottom, same thing. So shorter side, just the same as the wall. We will simply just negate the y component, and it'll go the opposite direction. And if you have ever seen Pong before, if it hits the shorter side, it's just going to go, it doesn't really matter. Like we wouldn't have to, you don't necessarily have to do it this way. You don't even have to detect if it hits the shorter side, because it won't matter in terms of points, but you know what, we're going to do it for completion. Now with the longer side, it's a little different, because if this is the paddle, and this is the ball. It's going with some velocity vi, and we want to leave with some velocity vf. Let's say the paddle isn't moving right now. So this is our normal. Same principle, except we're just going to negate the x component now. So vfx is equal to negative vix. And this works on the right and left side, because if it's moving to the left here, it has a negative x velocity, and we want to have a positive x velocity. And if it's on the right side, it's going to have a positive x velocity, and we want it to have a negative x velocity. Alright, so now let's look at the situation where the paddle is moving. So we have this, our paddle, but this time let's say the paddle is moving with some vp, and this is completely in the y direction. So it's like this. So the process is going to be similar, except it just has an extra y component in there. So we'll start by just negating that one component. So v1, v2, and vf. So we're going to have some intermediary. Or I should actually call this vi. So this is theta. So v2x is equal to negative vix, and v2 is some intermediary velocity. However, vfy is equal to v2y plus some constant times vpy. I haven't written this code yet on my own, so I'm just going to determine if this constant is necessary. But it might not be necessary, to be honest, because if we just, it's gonna have some extra y component, because if, I don't know, that's just kind of how it works, and it also makes it go faster. If you increase one component, the magnitude of the Pong ball actually increases, and the magnitude of the velocity increases. So therefore, it will start moving faster. Let me actually just check one quick thing. This might, I'm just realizing it now, but no, it works. I'm sorry. I was thinking about, like, no, never mind. It's fine, don't worry. Alright, now for detections. We are 13 minutes in, and I'm already halfway done with my water. This is not boding well. Alright, so now for collision detection. Let's start with the wall. It's easiest. So once again, you'll have your rectangle here. And we'll look at a collision on all four sides. So ball like that. Or let me just okay. Let me just use a oval. Okay, so let's say we had one there. God, this album, it's called Excursions, if you were wondering. It's by C418. This is one of his lesser known albums. I found it a little bit ago, and it's just so nice just to play while you're doing work or something. Like, it's very just soothing. Okay, so let's look at let's look at this. So this is the top wall right here. So this is the center. Now let me actually get the thinner pen out. There we go. Was that the thinner pen? Holy crap. That is thick. How do I color and thickness? There we go. Oh, there we go. Alright, that's a little better. So that's the paddle offset, I believe. Is what we call it in our program. So it has an X and Y. I'll just say X, Y. And this, the Y coordinate of the wall is just height. Just like that. So what we want to do essentially is just say we have some radius, right? And it's I assume it's pretty obvious that if r plus y is greater than or equal to height, there's a collision. Now similarly, on the right side, we have to say r plus x is greater than or equal to width. That just changed thickness. Now at the bottom, we're going to say r. No, we have to go height. Wait, no. Sorry, what did I say? Not r plus y, r plus x. This time it's y minus r is less than or equal to 0. No, no. You know, I need to change my freaking key bindings, but holy crap, this. So r plus x is greater than or equal to width. Then down here, we say, okay, if the y position, this one, if that minus r, so subtract r, is less than 0, so this point right there is x and y minus r. So if y minus r is less than or equal to 0, we have a collision at the bottom. Left side, pretty similar. So x, it's just x minus r is less than or equal to 0. So that's how you detect collisions with the playing field. Now for let me actually just write that. For the actual paddle, it's going to be a little more complex. We're going to have to apply some geometry. And the reason why is because it's not just a line, right? Like the paddle is something right here. And let's say we were looking at if r plus x is greater than or equal to the x position of the paddle, we would get that would return true for this paddle right here. But even though it's not actually colliding, and the reason why is because r plus x is greater than or equal to width. So what we're essentially going to be looking for here is just an intersection on both axes, so the x and y axes. And it's going to be a couple of things. So let me zoom in a little. So we're going to look at the paddle. We're going to look at the ball. The first step is to take the difference in the centers. So the center to the center, we're going to take the vector difference, and let's call this d. Distance difference, whichever one you want to call it. So this ball has a radius, and this paddle has a half height and a half width. And we can actually calculate these already in our program, so we don't need to worry about that right now. So what we need to do now is, so we get the center of the paddle and the center of the ball. What we have to do here is determine if there's overlap in both axes. So we're first going to say if d dot x is greater than half, or let me just say hw for the half width, plus r, return false. Or d dot y is greater than, and this is going to be the absolute value. Yeah, we're just going to get the absolute value just to make things easier here. So if d dot y is greater than h plus r, right? Yeah, we're going to say there's no collision at all. So we'll return something like -1. And I mean, that kind of makes sense. If this distance, if the x, so it has an x component and a y component. So let me just label those right here. So we have d dot x and this is d dot y. If d dot y is greater than half height, this thing right here, plus the radius, then there is no intersection on the y-axis. However, you see that there is in this case. However, in the x-axis, the x distance is actually greater than the radius plus the half width. Therefore, there is no intersection on the x-axis. Now, to determine what axis there's actually a collision on, because this we know that there is definitely not. So this is determined that there is definitely not a collision. Not a collision. Why is this thicker actually? I need to get the thinner, or you know what, fine, it works. So we know that there is definitely not a collision if either of these conditions pass. Now if d dot x is less than or equal to half width, we know there is definitely a collision on the x in the x-axis. This is some physics. Yeah, it's no, it's more like geometry, I'd say, but it does involve velocity and vectors. So if you consider that mainly physics, then yeah, this is some physics, as you say. So if the x distance is less than the half width, we know there is definitely a collision, like that it is definite, and we can say we can return some number like 1, and we can map 1 to an x direction collision. And the reason why we know that there is definitely is because we have ruled out that it is not, that there, I don't want to say this. This takes care of the case that there is no collision on either axis. So no collision on either axis. So if we know that there is collision on one axis, on at least one, then we just have to determine which one it is. Now if d dot x is less than or equal to half width, then that's going to be something like where the distance is, where the radius is something like right there, and d dot x is within that, and you can determine, okay, I know that that is exact, so the center is essentially contained in the rectangle. So center in rectangle. And then we'll do something similar for the x, or for the y direction. So if d dot y is less than or equal to half height, return 2. And once again, we'll return 2 to map that to a collision on the y, on the top or bottom. I meant to say center, the centers in rectangle. 1 will mean, here, one second, let me actually just turn my fan off, I'll be right back. So if we return 1, then we're going to say that there is a collision on the longer side. So so collision on length. And if we return 2, it's collision on width. And if there's a collision on the length, we'll just reverse the x direction, or the x component of the velocity, and if there's a collision on the width, we'll reverse the y component of the velocity. So stuff that we've already seen. Now, next we have to take care of the corner cases, because this doesn't take care of something like where the center is not contained. Because if the center is out here, well, actually, no, this does take care of that, I'm sorry. Because, you know, it takes care of that, but it doesn't take care of the corners exactly. Because think about, if the center's out here, the distance like that, the height, the y component and the x component are both greater than the height and the width, the half height and the half width, respectively. So therefore, we have to use the Pythagorean theorem. This is more geometry. So we have to get the squared distance and compare it to the squared radius and determine if it's less than, or we have to essentially get, how do I want this? We have to get this distance right here. So the distance from the corner to the corner, or from the center to the corner, and determine if that distance is greater than the radius. And if it is, then there is no collision. It'll be something like out here, like that. But that's not accurate. So you'll see how it works in the code. So next we have to get so we're going to say the squared distance. So if I'm going to say d dot x minus half width squared. I'm just going to use math notation right now. I'm not going to say dot power or times the same thing, plus d dot y, or minus half height squared. I just changed with the, you know, fuck it. Minus half height squared is less than r squared. Return, we're just going to say 1 and just treat it as a length collision. Otherwise return -1, return 0, whichever one you want. You know, we should return 0 if there's no collision, actually. Just because that'll be easier for like a if statement. So a little more explanation on this. So we have our one second. Hello, Gabrielle, or Gabriel? Yeah, it's Gabriel. Sorry. Yeah, so if you're just joining, we're looking at 2D collisions in with the Pong ball and the paddle right now. So we have this is our distance vector, so the center of the ball and the center of the paddle here. Now, half height is something like this, and half width is something like this. So treat the box, I'll just draw the box in like this. So like that. So we have half width and half height. And if you draw a vector to the corner of the box, it turns out that from the center to the corner of the box, it turns out that the components of that vector are half height and half width, because that's just the difference between the corner and the center. And in a rectangle, that is wait, what did I say? Yeah, that's the, it's just essentially to get to the corner from the center, you just add half the height and half the height in the y direction, half the width in the x direction. And to determine the distance to the corner, we just have to draw a vector from the center of the ball to the corner, get the distance, which is some value, and if that's less than the radius, or if the radius is something like this, so if that's our ball, if our ball is like this, the distance to the corner is less than the radius, or is greater than the radius. So we're going to return false, there's no collision, but if the radius is greater than the distance to the corner, then you see that there is a collision with the corner. And we're just going to say, okay, this is just a length collision, because it's just simpler to do it there instead of having to do it otherwise. Alright, so now let's actually do some code. And I'm going to run into some difficulty at some point, just because I have not I'm good at drawing. No, I'm not. This blows ass. Alright, I mean, it looks nice because it's on one note, but it sucks. Yeah, so I haven't written this code yet. So I'm gonna be might be a little rough in some patches, but I kind of know the general direction in which I want to go. Why do we need F stream? And why is this so thin? I didn't change this. Okay, I don't know. Okay, so first thing I wanted to do was create a structure for a 2D vector, just to organize things a little more instead of just using arrays. So we'll have a 2D vector structure. So struct vec2, and we'll just take in two float components, so float x and float y. And I'm actually going to put these into our data because structures actually store these components consecutively. So it'll read it as kind of an array. Alright, you gotta go, Gabriel, or fuck. Gabriel, what'd I say? Alright, I'll see you later, yep. What was I saying? Yeah, so in memory, the x and y are stored consecutively. So you can kind of send this in as an array, and if we have an array of these, it'll store x1, y1, then x2, y2 all consecutively, which will be very nice when we want to pass in data to the GPU. And we've already seen this with array lists in the OpenGL engine that we've created before. So let me find out where I want to put this. Okay, here we are. So we're going to be changing a couple things. This video might be a bit long. That's unfortunate. Okay. So I'm going to start by setting up. I'll leave the vertices as they are because I don't really care too much about that. The offsets, however, I do want to change. So we have our offsets arrays type float, make that a vec2d, vec2, and that's going to give a lot of, you know, I actually want to test something real quick. I'm going to go to the front here, top. I'm going to create a 2D vector, and I'll create an array, just test. I just want to see if it actually interprets this as two 2D vectors. I don't know if it will, but I'm going to put a breakpoint and just see if this actually works. So vec2 test, and we don't know what it is. Doesn't like it. What? You know, let me just put the breakpoint up here. Test. Oh, it does do it. No fucking way. That's actually sick. But why can't I find it? Where? Why is it not showing up here? I'm actually confused. Alright, so it actually interprets that. That's nice. Okay, so we don't need to do too much reformatting. That's all that matters. Okay. So that's nice with C++ advantages. Okay, so where were we? Paddle offsets. Just make it a 2D vector array, and it will automatically interpret this as a 2D vector and this is a 2D vector. Same with the paddle sizes. You can make that a vec2. I don't know if it's going to like this now. Yeah, it's not going to. So gen buffer object, we just have to change it to vec2 now. And then change it to 2 times 1, because there's one, or wait. Yeah, 2 times 1, because... Am I doing this? Wait. The 4 was the number of floats. Okay, yeah. So you can just make it 2. You can remove the times 1. That was just for illustration purposes because there were 2 floats per, but now because we're using the structure, it actually makes it a little easier. And you can also change the set at pointer to vec2. And then we have to change size and stride. Okay. Or you know what, you can leave the set at pointer as float. I don't want to change too much and get a bunch of errors. Now for the size VBO, just do the same thing, so make it a vec2. And then just say it's 1, because remember we only have 1 paddle size. Like that. And then we can do the same thing for the ball. So ball offsets, make it a 2D vector array, and then the ball sizes. We can leave the vertex array as a float. Just I'm too lazy to fix that right now. So once again, just change the generate buffer object to vec2 as a template just for the offsets and size. And you can also just change that to a 1 and a 1 because there are only 1 of each. We only have 1 ball, so we have 1 size and 1 offset. All right, that's pretty cool. Okay. For update data, change the panel to change the template argument. So we're in the main loop now. Just change it to vec2 in both spots, and change the number to 2 and 1, 2 paddles and 1 ball. All right. Now this should be. Oh, okay. So now it doesn't like the process input. Oh, okay. So now in process input, all you got to say is just make it a vec2 pointer in there. And then we need to say paddle offsets. If it was 1, so the first, so for the left paddle, change the paddle offsets at 1 to paddle offsets at 0.y. Because that was essentially the y component of the first offset before. And change the at 3 to 1 and then .y as well. God, this fucking album is just so, oh my god. It's just so mind stimulating. Okay. This should be good. That sounded really weird. But, you know, it's just, ah, my god. I don't know why. It's just so fucking good. Alright, let's run this. Yeah, it fucking works. Why is that using 85 megabytes? I'm really confused, actually. Alright, I don't really care. Alright, sick. Alright, nice. Alright, so now that we've updated the memory type, we can now implement some of these physics. So let's first oh, okay. The one other thing I want to do is in the frame buffer size callback here, I want to also do something. I want to reset the offset of the right paddle, because if we update the width, like I don't want this to happen, where the right paddle just stays in the same spot. So I want to have it kind of set, or what is it? I want to have it update that. So the first thing we're going to have to do is make the offset, and the paddle offsets, make that a public array, and the ball offsets as well a public array. So at the top, underneath graphics parameters, or underneath the structure definition, just have our public offset arrays. So we're going to say vec2 paddle offsets, and just create it with size 2, and vec2 ball offsets and create it with size 1. Right, and then now in the main method, when we actually set those variables up, just change it so that we can just say just initialize each element individually. So paddle offsets at 0 is equal to 35.0 float, and screen height divided by 2.0 float, and then paddle offsets at 1 is equal to screen width minus 35.0 float, and screen height divided by 2.0 float. Yeah, so this is the thing I wanted to change right here. So you can delete the offsets array that we declared in the main method, because it's declared outside, and then do the same thing for the ball offsets. So ball offsets at 0 is equal to this array. God, this fucking song slaps. Holy shit. Alright, so let's actually just run this just to make sure everything works still. Yeah. Alright, good. Now in the frame buffer size callback, we just have to update the right paddle's X position. So paddle offsets at 1 dot X is equal to width minus 35.0 float. Just like that. And it should update every frame. So if I extend this, it gets it. Alright, nice. So yeah, it gets updated. Nice, okay. And you know, this can actually make some cool shit, actually. I'm not gonna lie, because if you have something like that, you could just make the Pong fucking massive. That'd be kind of cool. Yeah. Alright, so now let's actually get into the physics. Okay. So let's let's actually get the moving ball first. So let's make another 2D vector global. Another global 2D vector. And say vec2 ball velocity. And we're gonna initialize it just as 0, 0 for let's make it 1, 0. Right, and we can see it move a little. So when we create the ball, we'll just say ball velocity dot x is equal to 1.0 float, and then in each frame we just gotta say So we're gonna update the positions first, and then update that data in the GPU. So above where we say update data vec2, we're gonna say ball velocity dot x plus equals, or no, sorry, ball offsets at 0 dot x plus equals ball velocity dot x. And I'm pretty, you can also make this, you can also remove the ball offsets array and just make it a ball offset. You know what, let me just do that actually, just because I don't feel like making an array out of this, because it's just very useless to do that if there's only one. Alright, so ball offset, this should give us a bunch of errors. I'm looking for them. I'm not finding them. Where are the errors? Alright. Oh, here we go. Okay. So one, and just say a reference to ball offset. So in GenBuffer object, the data that we should pass in is a reference to ball offset. And the same thing in the main method, just say ball offset.x plus equals ball velocity.x. And then in the update data, just say pass in another reference of ball offset. Alright, so, and then similarly, we should say ball offset dot y plus equals ball velocity dot y. Alright, so now let's run this, and if it moves, ooh, yeah, it fucking works. And there's going to be no collisions, and it just keeps on going forever. We'll determine this an initial speed, but remember this is in pixels, so it might be a little different or weird to think about. You could probably normalize this stuff, but I'm going to keep it as pixels, just in case the window is actually resized. Alright, so let's worry. So now that we have it moving, let's worry about the wall components. So update the position. Then we want to check for collision. So then this is so I'm just going to section off, or I'm going to create sections in here in my main loop. So graphics, then physics. I also wanted to create a velocity array for the paddles, just because I don't want to pass in an offset to the input method. So I'm just going to say public velocities. So then just make an array of size 2 of vec2 and call it paddle velocities. So like that. Is that my mouse wheel? I think my mouse wheel's squeaking. That's great. Yeah, that's unfortunate. So when we set the paddle sizes, you can just initialize that array to 0. So paddle velocities at 0 is equal to 0.0f and 0. Wait, no, it only has to be 1. Oh my god, that's right. So we can make that a float array. So you can actually just make this a float. Paddle velocities, since we only care about the y direction. So paddle velocities at 0 is equal to 0.0 float, and paddle velocities at 1 is equal to 0.0 float. And then in the process input method, we want to pass in a float. Or you know, we don't need to pass in any more offsets because that array is public. So what we got to say now is we want to set the velocity of the paddles. So so let me say this. So essentially, where we say paddle offsets at 0.y plus equals, just change that to paddle velocities at 0 is equal to paddle speed. And then above this, in the top of the process input method, we want to set them to 0 just so it doesn't continue moving even when we don't have the button pressed. So paddle velocities is equal to, or at 0 is equal to 0.0 float, and paddle velocities at 1 is equal to 0.0 float. Once again, this is just so if you press the button once, it doesn't just set the velocity and it doesn't get reset to 0. So just if you so if the W key is pressed, we want to set the paddle velocities at 0 to paddle speed. If the S key is pressed, we want to say paddle velocities at 0 is equal to negative paddle speed. Because remember, we want to go down. And then similarly for the bottom, we want to say paddle velocities at 1 is equal to paddle speed. And then same thing on the bottom, paddle velocities at 1 is equal to negative paddle speed if the down key is pressed. Now, back here, I'll just leave it there for a second. Oh, I forgot to multiply the speed by dt in the main loop. So in the main loop, remember we have to use dt. And that parameter is no longer necessary. Oops. So update ball position. So when we say update ball position, just say ball velocity.x times dt and ball velocity.y times dt. So we are going to have to we are definitely going to have to increase that velocity. So above the ball position update, we want to update the paddle position as well. So what do we want to do? So paddle offsets at 0 dot y plus equals paddle velocities at 0 times dt, and paddle offsets at 1 dot y plus equals paddle velocities at 1 times dt. So this should all make sense here. Once again, we're just multiplying the velocity times the change in time to get the change in position. That's why we're using plus equals here and not just equals. So let's actually run this, see how it works. You see the ball is moving a lot slower because it's being multiplied by a dt. So let's increase this velocity actually. Or speed. So paddle speed, or no, not the paddle speed. Where did I set the ball speed? Oh, no, it's ball velocities. Yeah. So where you set ball, this is going to take a lot of trial and error. So, where we say ball velocity, you can just change it to some value. So ball velocity, I'll say, is equal to 1.0 float, or 10.0 float, or let's say 20.0 float and 20.0 float. Just like that. We run this. Alright, that's still way too slow. Let's say 100. That's going to be a lot faster, but you know what? It'll look nice. So I've run it. There we go. Okay, that's a little more up to speed, I'd say. Okay, so now it's actually, now we can do collisions. Alright, okay, so in the physics section underneath where we update the positions, we're going to now update the velocities, or we're going to check for collisions. So this program structure is very, I'd say it's very similar, but it's also very cluttered. We're at 500 and something lines, and I don't want to add another file because that would just make things a little more confusing, and this program will not be that big. I mean, unless we do networking at some point, this is not going to be that big. I don't know. Yeah, alright, so let's just get for the collision check. Okay, so let's check for collisions first with the, oh, that's bright, holy crap. With the playing field. So, first with the playing field. So what we're going to say here is, how do I want to say this? Or how do I want to write this actually? Because I haven't written it yet. So if, so let's check the top and bottom first. So if ball offset dot y minus ball radius is less than or equal to 0, collision with floor. So we're going to reverse the y direction. You know, we can actually just say, or ball offset dot y plus ball radius is greater than or equal to wind height. What is the SCR height? Okay. So you can actually check both of these at the same time because we're only doing the same thing. So floor or ceiling. So we just got to say ball velocity dot y times equals -1. So let's see how this works. So let me make the ball velocity initially slower in the x direction. So just so we can see it actually. And I hope it works. Oh, please. Yes! Let's go! You'll love to see it. Alright, moment of truth. Atta boy. Atta fucking boy. You'll love to see it. Oh my god. Alright, so that collision works. Now we gotta check for the left or right, but we're not gonna, we can just print something out. So else if ball or what is it? I'm gonna put this, I'm gonna do something that you, I don't know how I can actually do this. Let me, I'm pretty sure this is gonna give me an error, but I'm just gonna check something real quick. So the next if statement will be for the left wall. We have to check the left or right and right walls independently, because we actually do something different for both sides. So if ball offset dot x minus ball radius is less than or equal to 0, collision with left wall. So we can say standard cout player right player point, and once again we'll implement a scoring system next time. And else if ball offset dot x plus ball radius is greater than or equal to SCR width, collision with the right wall. So standard cout right player or left player point. And we also want to reset. Because if it goes past, we want to reset it to the initial position. So let me just see if this works real quick. Oh, you know, I should just make this fucking faster. You know, I'm gonna remove the times dt for the moment being, just so it can go faster. But you should not do this. Holy fuck. Okay, yeah. Alright, yeah. It's good. It's good. Don't worry. It works. That was quick. You know, I can actually just make it. Okay, so in order to reset, so I'll create a Boolean value in the main loop before we check for left and right collisions. So bool reset is equal to false, and if either condition passes, we're going to say reset is equal to true, because we want to reset the position. So reset is equal to true. And to reset, so next outside of the loop, we're going to say if reset ball offset.x is equal to scr width divided by 2.0 float, and ball offset.y is equal to screen height divided by 2.0 float. And I also want to reset the velocity to the initial. So what I got to do up top is create a global variable called vec2 init ball velocity, because we want to reset it, remember. So this is going to be equal to 150.0 float and 150.0 float, just like that. And then all we got to do is just copy those values over. So if reset, update, put ball in middle, and then also reset the velocity to initial. So to do that, we're just going to say ball velocity dot x is equal to init ball velocity dot x, and ball velocity dot y is equal to init ball velocity dot y. Okay, so now let's see if this works. All right, it's working good, perfect. So you see left player point, yada yada yada, whatever. I'm just gonna refill my water real quick. So yeah, I have a mini fridge in my dorm room, and the Brita filter is so fucking clutch. Just whenever I want water, just, you know, refill it. It's pretty nice. It's crisp. We're almost, oh no, we still have some time in here. God fucking damn it, this album, it's so good. Right, what were we doing? Okay. So collision detection with the playing field. Now we can actually do it with the paddle. Yeah. All right. Okay. All right. So let's get this shit on the road. So remember, we got to create our distance vector. That's the most important part about this. So vec2 distance is equal to and here I'm going to say I'm going to calculate each component separately, just because I don't want to implement a method operator, the operator minus method. I also don't entirely know the specific signature of it, so I'm just going to do it independently or individually. So distance, the first component is equal to standard ABS, because remember we want to get the absolute value of ball offset dot x minus oh, we're gonna have to check this for both paddles, son of a bitch. Okay, so let's do a for loop. So for int I is equal to 0, I is less than, or you know what we can do? We can do something cheeky here. We can do something really cheeky here. We're going to get an integer I is equal to 0. And if ball offset dot x is greater than screen height divided by 2.0 float I plus plus. And we're going to use this to index into our paddle array. Look, it's, I mean, yeah. I don't know if that's cheeky per se, but it just removes the for loop because you don't want to check both of them if you know it's on one sector. Obviously, this will create some bullshit if like you fuck up your window size like this. Like if you straight up just be a complete jackass and do that, like, oh. Why would, like, honestly, why would you do that? But like, oh, you know, I think I found a bug. We can't move the things back in. Okay, I figured something. Okay, so if you fuck your window size up like that, the paddle might get stuck off the top. So what we want to say is in process input, if paddle offsets at 0.y is less than, so we just want to say else, we want to set the paddle offset to that. So paddle offsets at 0.y is equal to screen height minus paddle boundary. So just do this for all of them. And so just so it sets it back if you try and press the button. And then in the, if S is pressed, you say else y is equal to just paddle boundary. Then in the bottom, it's going to be the same thing except you're using paddle offsets at 1. If you're having trouble keeping up with me just scrolling back and forth, I'm sorry. I'm all over the place. But look at the GitHub. This stuff will be pushed after this stream. So, and you can also pause it too. I forgot you can do that. Alright, so now let's just make sure that works. Because I'm gonna be kind of annoyed. Okay, there we go. Okay, good. We're sitting nice. Okay, we're sitting nice. I need to figure out if there's a way to prevent resizing the window, because then online play will not work at all. Okay. Alright, so now let's actually look for collisions with the ball. So if the ball is on the right side of the screen, use the right paddle, or check with right paddle. Otherwise, just leave it with the left side. Alright, so we're going to get our difference, so our distance, so vec2 distance is equal to a 2D vector, and we're going to say the x component is ball offset dot x, or remember absolute value, so standard ABS, ball offset dot x minus paddle offsets at I, so we're using the index dot x, and the same thing in the y direction, so standard ABS ball offset dot y minus paddle offsets at I dot y. Alright, just like that. Okay, just writing comments. All right, so we got the distance. Now we're gonna do our if statements. So first thing in check. Check if no collision possible. So if distance dot x is greater than half paddle width plus radius, ball radius, or if it's less than or equal to, and distance dot y is less than or equal to half paddle height plus ball radius. So the reason why I'm reversing this the equality operator now is because in this kind of implementation here in this pseudocode, that was like if it was in a dedicated function. But since we're just keeping it all in the main loop, I'm just going to say if both these conditions pass, just go into the body of the if statement and then do the collision detection there. Alright, so next we're going to say if distance dot x is less than or equal to half width, we have a length collision, or half paddle width. Else, if distance dot y is less than or equal to half paddle height, we have a width collision. And I'll also create another. I'll create a Boolean value called collision. So bool collision is equal to false, and I'll just set collision to true. So if collision is equal to true, we'll look at what that means after. So if there's a length collision, we want to reverse the x velocity. So ball velocity dot x times equals -1. And if it's a height collision, or a width collision, sorry, it's ball velocity dot y is times equals -1. Now, once again, otherwise we want to check for the the Pythagorean theorem. So else if, then I'm going to do the math right here. Or let me just get the squared distance. So float squared distance is equal to distance dot x minus half width times distance dot x minus half width. So that's squared essentially, and then plus, or half paddle width, and then just do the same thing in the y direction. So distance dot y minus half paddle height times distance dot y minus half paddle height. All right, just like that. And then we want to see if squared distance is less than or equal to ball radius times ball. We can just put this all into an if statement just to avoid the need for another variable. So I'll just put a comment in here. So squared distance is less than radius squared. So distance is less than radius. So once again, we're just gonna treat it as a length collision. Treat as length collision. So collision is equal to true, and ball velocity dot x times equals -1. Alright, now outside, or not outside, but after that, we want to say if collision add to the y velocity. So remember, we want to do that. So we're going to say ball velocity dot y plus equals. Alright, how do we, or, you know, once again, I'm saying I'm going to do the constant. So where is it? Alright, so after we have reversed the y component there, or we haven't reversed it, we just want to, or in either case, we want to add some value to it. So I'm going to say plus, so ball velocity dot y plus equals 1 times paddle velocities at I dot y. Did it not like that? Why doesn't it like it? Expression must have class... Oh, paddle velocities at I. That's right. Because it's just the y components. And then times dt once again. And we can have our constant float k is equal to 1.0 float. Doesn't matter right now, but we're just going to think about it. Okay. Using... I don't know if that works. Alright. So let's look at this actually. Is the paddle fast enough? No, it's not even fast enough, son of a bitch. Let's increase the paddle velocities by some value. Or increase the paddle speed, rather. So paddle speed is equal to, let's call it 150. So the same initial speed as the ball. Oh, it kind of works. There was some weird thing that happened. Okay, but it's semi-working. Look at that. It's semi-fucking working. Uh-oh. Oh, we fucking did it? Oh, okay. Yeah, so I messed up in my frame buffer thing. Or in the input. So, yeah, okay, I just forgot to subtract. Alright, or forgot to, I copied and pasted. So that's fine. You can do the reset the value after. That doesn't really matter right now. But what matters is something worked. It's just the Y. It was, do I want to do collision detection first? Because that might be the thing. You know, I think it is. I think it's collision detection has to happen first. Because what happens is the X... I don't know if it's actually going to make any difference. But, you know, I'm just going to see. I hope it does. I doubt it. I doubt it, actually. Yep. Alright, no difference. Okay. So, why is it kind of bouncing? Or... You know, let me actually just see if it actually speeds up just to make sure that it actually does. Is it? Still looks pretty 45 to me. Alright, there's some I think this is an error with the collision detection system. Yeah, I don't know if this is this. I don't think this is working, unfortunately. Okay. Alright, I need to do more research then. Alright, it's also not doing this. Alright, let me just see if it's speeding it up. For some reason it's not. Okay. Ball velocity dot y is equal to 150. Oh, it's because I multiply it by dt. Don't multiply the velocity by dt. I forgot that. Yeah, so just make it the k. Alright, so now it should be good. Oh, shit. Is it going any faster? I don't freaking know. There, okay, it is. It's... Ooh. I should probably remove the... I should make it a little slower, actually, so like 0.2. Just to make the effect, or 0.3, just to make the effect a little less apparent. But there's, I don't... It has to be an error with the collision detection. Like it thinking. What did I just do? Okay, touch my drawing board. Let me try removing the addition of velocity. See if that changes anything. That kind of worked, actually. Why did it go down? That's not right. I'm really confused now. Okay, it didn't help. But there was that weird bug where it just like started rolling. Alright. You know, I think I'm gonna try and just simplify this more. I'm going to determine if the center is... Alright, so I'm going to... Alright, you know, I'm going to do a proof of concept real quick on OneNote. I don't know if this... I don't know. It's weird, but... Alright, so let's say we have this, and I'm going to say... I want to see if alright, so I'm going to determine if it is a radius distance away from the x coordinate, and then also I'm going to determine if it's if it's within the y bounds as well. But if it does, I can't really say it's a length collision versus a non-length collision, which makes it a little tricky. You know what I could say? Is if it's... What about a radius distance from the y coordinate? Alright, so I'll first determine if it's in the x area. So let's see this. So if ball offset dot x, do we want to do plus or minus? Oh, this is, alright, this is going to be annoying. Alright, so we're also going to have to create some factor here. Or, you know, I'm just going to say plus I, here, I'm going to do a ternary operator here. So if I is equal to 0, we want to do minus radius because we want to subtract the radius to get to the left, and if it's not, we want to go to the right. So I is equal to 0, minus radius plus radius, or ball radius. And if this is less than or equal to paddle offsets at 0 dot x plus half paddle width. Alright. I hope that looks fine. So if it is possible collision, and it's greater than, God damn it, this is annoying. Okay, so I gotta see and... Shit. I don't think I'm gonna be able to do it like this. Because this is gonna be too many if conditions, then that's gonna be messy. This algorithm is so nice, but it's just not working. Alright, you know, I'm just going to try this right now. So this condition that we just wrote, so ball offset dot x plus or minus the ball radius is less than paddle offsets at 0 plus half paddle width. So this condition, and it has to be greater than the other side. Or paddle offsets at I, rather. That should be it. Alright. Plus half paddle width. Son of a bitch. Alright, I don't think this is gonna work. Yeah, this is gonna be too many if conditions, alright. I just need to determine why it's... Alright, you know, I'm gonna try something out here. Alright, I'm gonna make this window smaller so I can see the actual game on the right side. Oh, build error is great. Alright, let's run this. Alright, G-force, get out of the way, get out of the way, come on, get out of the way. Okay. So it stops there because it found a collision. Why? Why did it find a collision? Or, oh, because it hasn't updated the position yet. Okay, right. So it hasn't rendered the updated position. So let me go to the next frame. Continue. Okay, so yeah, that's a collision. Good. So now let me see what happens to the velocity and stuff. So process input, good. Update. So paddle velocities, 0. That's fine. Alright, so that's the paddle. I don't really care. Ball offset now. So ball velocity is 150, 150. Has not changed. Okay. So I believe that's why. It's not changing the velocity, but it... Why wouldn't it be? The only way collision is true is if we change the velocity. Alright, I'm going to create a breakpoint. I'm going to remove... Let me just make this a little bigger. And then create breakpoints where we actually set collision to true. Because I think this algorithm works, but I just need to figure out why it's... Because it's definitely something on my end where I'm changing the velocities incorrectly. That sounds right. Alright. Okay. So... Width collision? Why would it be width collision? Okay, that's why then. It's finding a width collision when it shouldn't be. Because that's going to be a... let me just put the position update to after, just so we see what it is in real time, or in the same frame rather. Alright, so now let's see. Oh. Alright, what is it? Get out of there, GeForce, I don't care. Okay. So it found that that's not a collision though. Alright, let me just add that back. Oops. Alright, that's just a straight up collision. Where it's finding multiple collisions. Okay. Once again, did we finish the album? Son of a bitch. Okay, we did. I'll put some I think we'll chill without music for just a little. Why is that a width collision though? Distance.y is 8.199. Half paddle height is whatever. Distance is 11 point. And paddle width is 10. Okay, I think I'm getting there. I'm getting to understand this. Because it's figuring out that the distance in the y direction is 8 when that is certainly not. Wait, no, that's right, yeah. Distance.y is less than or equal to half paddle height. But then also it has to be greater than half paddle height minus radius. Right? Yeah. Yeah. Because it's figuring out that it's 8, but it's not colliding in the y direction. So this condition has to also read, and distance.y is greater than or equal to half paddle height minus ball radius. And then the same thing in the width. So and distance.x is greater than or equal to half paddle width minus ball radius. Yeah, okay. So once again, the reason why is because it was where fuck, where'd I go? So it was finding that the ball, when like over here, was less. So here, let me just look at that. So if we look at this math again. So the red vector, here, let me just draw this out real quick. I'm going to say the solid red line real quick. So this is the distance vector, right? It was finding out that the distance in the y, so it was like something out here. So that y value was less than half the height, even though it wasn't colliding in the y direction. So we have to make sure that it's in this. It has to be in this bounds, or in. No, sorry, wrong one. Has to be in this bounds, where this is the height and this is the height minus radius. So yeah, that's why that I had to add that extra condition in both directions. All right, so now let's run this again. And let me just disable the breakpoints and hope that it works, because I don't want to break this again. Please, just please. That works, kinda. It was going into the thing, but that's fine. That it's not glitching, and it's also going a lot faster. Oh Jesus Christ, that's fast. Okay, good. Attaboy. You know what? I can live. I think that's fine. That's actually very good. The one thing I did want to change was if we had to reset. There was we say we're gonna, so if it was reset and it hit the right wall, we want it to go left this time. So we want it to go to the player that just got a point. So what I'm gonna say is I'm gonna make a reset an unsigned char to make it a code. So reset is equal to 0. Then if it's the left wall, make it 1, and the right wall is 2. So we're gonna set the x velocity to reset is equal to 1, and if it's the 1, we want to make it positive, otherwise make it the negative x velocity. Dot x, okay. So reset will be true. This will return true if reset is not equal to 0. So 1 or 2, but not 0. Alright, so let's run this again. Alright, good. I'll let the thing win. Alright, good. And then Go the other way. Perfect. All right, it's working. Oh boy, it's working. All right, let me just make sure that the height collision or the width collision is still. Oh, okay, yeah, it's fuck. It's boned. Why did that happen? Alright, we still have some bugs to fix, but it's looking okay for now. So if you wanted bare bones, you can stop watching, or you can stop watching now, but if you want the complete debugging of this, because I need to figure this out, although it may have been just when it was like perfectly on the top. That's hard to kind of replicate, to be honest. Like that's a good collision. That's a perfect collision. Oh, that's too bad. Okay, yeah, that I don't know about. You know, the velocities canceled it out. Okay. That's right. Oh, you know what? Okay. So, next thing I want to do is when it collides, I want to not only update the y velocity, I also want to multiply the x velocity by some value. So, ball velocity dot x times equals 1.01. So it just barely speeds up in the x direction because it's still kind of going slow. So you can't really. I should probably make it a little more, but okay, yeah. You see that was not. All right, so the height. Okay. So this collision is now when it collides with the width. That's something that's not. Oh, you know why? Because it's checking for this too. And then it's doing both. So we have to say these conditions here, so the squared radius and not collision. So we want to fall back on this is the last case resort, so fall back on it. I know yeah, okay. Now it should be okay. Still gonna be hard to test. Fuck. It didn't work. See, the problem with the radius detection is that you can't really. It's hard to. It's hard to say. You can't determine what plane it's colliding with. So you know, here, how about this? We let's determine if distance. So let's do this. So let's get the distance to the corner and determine if it's larger in the x direction or the y direction. And if it's larger in the x direction, we want to collide it with the width. So we're gonna say here. So if I just got a news notification on my phone about the debate, and I'm so fucking happy I'm not watching that. I do not want to involve myself with politics right now. I swear to God. Oh my God, I don't want to. I heard it was a shit show, and I'm not in the mood to talk about it. Because I'm probably not even going to watch the highlights, to be honest. I really don't care enough about it. Alright, so once again, back to the square distance. So we're going to determine if it's closer to the height or if it's closer to the width or the length. So if distance dot y minus half paddle height is here, let's determine this. So if distance dot x minus half paddle width is less than or equal to distance dot y minus half paddle or let's do it the other way around, because I want to prioritize the x, or the length collision. So distance.y minus half paddle height is less than or equal to distance.x minus half paddle width. And if it is, I want to multiply the x, component by 1, or by -1. Otherwise, I want to do the y component. So if closer to length, treat as length collision. I think this will fix it. Else, treat as width collision. So ball velocity dot y times equals -1. Alright, so now let's see. Still kind of fucked up. Ooh, okay. That didn't look right. I'm thinking of adding. Okay, that also. You know what? Okay, So my theory right now is I'm gonna add some sort of buffer in between collisions. So it seems like it's colliding twice in like 3 frames. So what I want to create is like a counter of frames since last collision, and if that value is something, then if it's greater than some value, then I want to be able to check for collisions, but if it's less than some threshold, I don't. So let's do this. So outside of the while loop, I'm going to create collision check buffer. So unsigned int frames since last collision is equal to -1. So what we're going to say now is, and we're going to create unsigned int frames threshold, and let's say is equal to 10. So 10 frames. So now when we do collision detection, just in that section, just say if oh, here, let's increase it first. So if frames since last collision is equal to, or is not equal to -1, just increase it. So frames since last collision ++. And then down here we want to say if frames since last collision is greater than frames threshold, we want to do the collision detection. So just take everything that we wrote for collision detection and then put it in there. Just update the indentation, and then we want to say if frames since last collision is greater than frames threshold, or frames since last collision is equal to -1, because -1 is the initial. So next, let's say, or let's do greater than or equal to. So now let's say if collision down here, frames since last collision is equal to 0, because it collided this frame. So if not many frames since last collision, don't check. Or, let's only do this for the paddle. So for the wall collision, you can keep the wall collision out of that. So the wall collisions we should do every frame regardless, but the paddle collisions should only be done if the frame since last collision is above that threshold. So do every frame, and then I'll do the paddle collisions. Let's say do only if it has been a certain amount of frames since the last one. Alright, so now let's run this. So it should not have that like double collision where it just screws up. I hope that that's boding well so far, and don't know. Or I just missed that. Guys, I'm okay. I'm good at this game, don't worry. I'm good at the game. It's okay. Fuck. Oh, that was good. That was good. That was good. That's also good. Because it's closer to the height, so it should bounce the other way. Fuck, that was not... I'll give it a pass. Yep, that's right. That's good. So it's a little... Yeah. Oh, because it was closer to the back. Okay. Alright, so now I need to know what I know what I need to do. So when we say if distance.y is greater than half paddle height, I really mean if the actual distance. So I don't want to get the absolute value of the distance. I want to get the actual distance because it was seen that it was closer to the back side of the paddle than it was to the width, like the back length of the paddle. It was closer to that than it was to the width. So I want to say, instead of distance.y, I want to say ball offset.y minus paddle offsets.y, and replace that. And I'm going to say use signed difference, because how do I want to phrase this? Use sign difference, because don't want collision with backside. Okay. So now let's see how this works. Alright, that's good. That's good. Oh, I suck at this game, I'm sorry. Okay. That I'm questioning. I'm questioning that. That's fine. I need to get like a perfect fucking collision. I don't know how though. Okay, I just missed that straight up. Because it seems like it's going into the fucking thing. Alright. No, I'll give it that one. That one looked like it was a width or a length collision. All right. Oh, that was just fucking wrong. Oh shit. Oh, because it has to be negated if it's... Wait, it can't be that. It's only the negative difference for if it's the... I don't want it to be ball offset.y is only negative if it's the left paddle. But if it's the right paddle, that difference should be positive. Okay. All right. So now I see. Okay, so how do I Alright, so float signed difference is equal to ball offset.y minus paddle offsets at i.y. And then, so that's the signed difference. But this I want that to be negative on the left side. No, oh wait, no. I want it to be positive if it's on the left side, but negative if it's on the right side. So now I'm going to say if I is equal to 0, signed difference times equals -1. I can actually just say if I, and then make this paddle offsets minus ball offset dot y. Okay, so let me just re-explain this. So if checking the right paddle, want to consider the difference if I think this is gonna work. I just don't really know how to explain it. I kind of want to I just want to reverse the difference. Want to reverse difference, just because I want to the left of the paddle, because want to the left of the paddle to be positive. Okay, that's why. Alright. Alright, errors. Okay, didn't put a semicolon. Alright, so now we should be all good. That looked good. That looked good. Ooh, that was good. That was very good. That just missed it completely. Don't worry, guys. I'm good at this game. Come on. Yeah, okay. All right. I just need the speed up to be more evident. I'm just questioning. Alright, that's fine. I see the speed up a little bit. I just need to make the constant a little more. This is actually getting difficult. Fuck. Fucking shit. Let me say if I is equal to 0. Let me see. Wait, so paddle offsets at I minus ball offset at y. That will be negative on the left paddle. God, this has been 2 hours and I've actually just been reasoning through this. I mean, at least I'm reasoning on stream. That's kind of okay. 600 lines, holy shit. So for the left paddle offsets at y minus ball offset at dot y. I want that to be negative. Or, you know, what if I did this? Paddle offsets at dot y plus half paddle. Wait. No. Distance dot x minus half paddle width. Do I want to subtract it? I wanted, Alright, let's think about this. So paddle offsets, that's going to be negative if... Oh, I want the sign difference of the x coordinate, not the, I don't give a shit about the y coordinate. Okay. Alright, yeah. So it should be... So this should be if distance dot y is minus half paddle height is less than... is less than... I was thinking of the wrong dimension. Signed, Okay. So now this should because I want this to be positive, but yeah, okay. Yes, okay. Yeah. Okay. Alright. I don't know. Fuck. That's good. I was thinking of the wrong, please. Fuck, I can't play this game. I cannot play this fucking game. No! I need to learn how this freaking game works. Holy, it's literally just, fuck. I'm gonna get angry. It is 11:12, and my brain is dying. That looked good, actually. Oh, okay, that's fine. I think I need to add a little more. Yes, okay, it's working. Oh, that's great. Okay, I think. Okay, it's good. It's good. All right, let me take a breath. Okay, it's good. So I just think the next thing that I'll do next time is just add like a more drastic Y difference if it's further down the paddle, just because that difference is not enough. I can say 1.02 or 1.05. All right. Oh, Jesus, that was long. 2 hours and 1 minute. That is for the record books. Yeah. All right. So that was kind of fun though. So I don't know. I kind of liked winging it on stream. I don't know. Interesting to think about, because I did have some notes with me. Like I had the vector notes, and then I kind of just tried to implement it by myself. I feel like for projects that might be better. Because if you're watching this to learn how to make a coding project, you'll probably learn how to debug one like we did there, and then also like how to reason through stuff using principles. But for tutorials, I'll prepare code, because that's just a tutorial, not a project. So yeah, that's how I'm gonna think about it. But anyway, yeah. So this has been fun. Well, it's long. I gotta go to bed, or I gotta finish some work actually. Son of a bitch. So yeah. Anyway, next week we'll be finishing this up, and then we'll actually implement the scoring system. I don't know if we'll be able to display it on the screen though, because I don't really want to download a library. So that might not happen, but yeah. So anyway, I hope you guys enjoyed, and I will see you next week. And yeah, or no, actually I'll see you Friday or Thursday when I play Minecraft or play some video game. But yeah, all right, I'll see you then. Adios.